Today we're going to focus on solving rational equations, and it's important to understand what a rational equation is before you get involved with working with these. A rational equation is an equation in which one or more of the terms is a fractional term with a variable in the denominator. We have talked about extraneous solutions, and this is not going to be the same thing as this word over here, either a restricted value or an excluded value. These are values that could not possibly be solutions to the equation because they would present a situation where your denominator is 0. And if you use your calculator, you can see that whenever you divide something by 0, it's going to say, probably says syntax error, or I can actually look and see what it does. If I say 8 divided by 0, and that's kind of hard to see, it actually tells you error, you can't divide by 0. So extraneous solutions, excluded values are going to be those values that make the denominator equal to 0. And you're not allowed to have those. And you would find those by setting your denominator equal to 0 and solving for x so that you could see what could the x not be. Sometimes it'll get in the way of the solutions you do find, and you actually have to say that can't be a solution. And sometimes you can just list it as a restricted value, and it's not actually an issue because it's not a solution that you'd find. We're going to do today in 2 parts. I'm going to go through and do a few examples, and then your classwork will be to go finish them, and I'll actually do a second video so that you can check your answers, just because some of these do get pretty tricky. So there's 2 ways to solve them. Way one is if it's just a proportion. Remember, a proportion is just a statement of 2 equal ratios. So you have a single term on one side and a single term on the other. You can set the cross products equal and then solve the equation. The other way is going to be a rational equation with unlike denominators, and that's where you're going to see multiple terms on one side. You need to find the least common denominator. You're going to multiply each term by the least common denominator, simplify each term, and solve the equation. It sounds pretty tricky, and they can get pretty tricky, but you guys are capable, no problem. All right, so we're going to start with number 1. This one's just a simple proportion. You got a single term on each side. So you have 2 equals x plus 2 over x minus 3. If you need to, you could always, say over 1. And at that point, you just have a basic equation or basic proportion. You can do your cross products. 2 times x minus 3 equals 1 times x plus 2. Don't need that 1 on the outside because we know the identity property. Then you're going to have to distribute 2x minus 6 equals x plus 2. And then you're going to solve just that pretty basic equation by subtracting x from both sides. X minus 6 equals 2. And then you would add 6 to both sides. X equals 8. Never a bad idea to go check it. 2, does it equal? 8 plus 2 is 10. Over 8 minus 3 is 5. 2 equals 2, so we're good to go. All right, so we have to look at restricted values. A restricted value, again, is where you might make the denominator equal to 0. So if we look at over here, if x was 3, and you can set this equal to 0, x minus 3 equals 0, x can't be 3. So that would be a restricted value. It didn't actually come into play and cause us an issue because we think x is 8, but it is still good to list those restricted values, and we're going to practice that. We're going to go ahead and skip right to number 3 because 2 is very similar to 1. You can do this part of your classwork. All right, so for this one, you got multiple terms on the left-hand side, so that does present a different problem. You can't just find the cross product. So you have to find the least common multiple. Not a big deal here. It's obviously going to be 6. So you do need to multiply both sides of the equation by 6. I actually show it times 6, but you can simplify it a little bit so you don't have to simplify more later. So over here, if I multiply by 6, the denominator clears out. And that's technically what we're doing, of clearing out the denominator. If you need to see it, you could also think about multiplying just individual terms. So this, to make it 6, I have to do it times 2, so the top times 2. So the denominator clears here, 2a minus 3 equals, if I multiply 6, I'm going to have 12a over 3. 12a over 3, and if you need to write it, you can, plus 6 over 2. I would fully anticipate that you could probably go straight to this line that I'm writing now. 12a divided by 3 is 4a plus 3. Then you just have your basic equation. I'm going to subtract 2a from both sides. So I have negative 3 equals 2a plus 3. Minus 3 from both sides, negative 6 equals 2a, a equals negative 3. So in this case, there is no x in my denominator, so there's no way for my denominator to equal 0. So there is no restricted values. And obviously, you can go back and check it to make sure that you're good to go. Probably the easiest way to do it would be in your calculator. Well, for this type of problem, negative 3 wouldn't be all too bad. But you could go ahead and put this store a, or x in your calculator is negative 3, and then you can go ahead and type that into your calculator. That's up to you. For number 5, we're going to skip number 4. This is very similar. Number 5, my least common denominator is going to be some form of x. 5 and 2, their least common multiple is 10, so it's actually going to be 10x. So I have to multiply everything on each side by 10x. Over here, if I multiply by 10x, that gives me 30x over 5x, which is 6. If I multiply it over here, I have 10x times 7 is 70x over 2x, so that's going to be 35. If you need to write it out in the beginning to get used to it, that's fine. Equals 10x. 41 equals 10x. X divided by 10, x equals 4.1. So that's the first part of my answer. Then we have to go look and see if there's restricted values. And there are. Either of these, if I set them equal to 0, x would have to be 0 to make the denominator 0. So my restricted value is x cannot equal 1. I'm sorry, x cannot equal 0. Okay, we're going to go ahead and move on to, we're going to go to number 7. I think 6 will be okay once we look at some of these tougher ones. Okay, so for this one, we have binomials in our denominator. I have m plus 1, m minus 1, and then I have no denominator over here. The least common multiple, if you think of this as a factor and you think of this as a factor, you have to have a denominator that contains both this binomial and this binomial. So what that means is that we're going to be multiplying everything by m plus 1 and m minus 1. And I'm actually going to show you everything for this. You might get quicker at it, but I think it's probably smart to see it all play out and how things simplify. All right, so if I multiply this numerator by m plus 1 and m minus 1, I'm going to have m plus 1, m minus 1, all over m plus 1, plus 5, m plus 1, m minus 1, all over m minus 1, equals m plus 1, m minus 1. You've probably already figured out that it may not be a bad idea to have a separate piece of paper out. Okay, so looking at each individual term, Here I have an m plus 1, and on the bottom I have an m plus 1. Those are just factors, so those can be factored out or simplified, just like if it was 2 times 3 times 4 over 3. I can cancel the 3's. I can cancel that and that. So now my denominators are just cleared out. So I'm going to go ahead and multiply to simplify. I have m times m, so I have m squared minus m plus 5m plus 5 equals, over here, difference of squares, so that's not too bad. I have m squared, and then I know my middle term will cancel out, so I have minus 1. All right, so to simplify each side, I guess I'm going to have to go to a little post-it note underneath it just to keep going. I know if I take away m squared from both sides, that disappears. If I clean up this side, I have 4m. 4m plus 5 equals negative 1. Subtract 5 from both sides. 4m equals negative 6. So m equals negative 3 halves when I divide by 4. Obviously, you could say negative 1.5 if you wish. Definitely take the time, plug that in, store that in your calculator, put this into your calculator, make sure that it equals 1. So you could turn a quiz in and know you have it correct. We do need to check for restricted values. That's where the denominator would be equal to 1. Over here, if m was negative 1, that would be 0. So m cannot be negative 1. M can also not be positive 1 because 1 minus 1 would give me 0. So those are my restricted values. All right, for number 9, we're going to do 9 and 10. Over here, look at this. I already have 5 minus p and 5 minus p, so that's kind of nice. You could even condense it to one term if you wanted to, and then you could do a proportion. Or you just know, if I multiply each of these terms by 5 minus p, that clears the denominator out. That's not so bad. And then over here, got to keep it even, 5 times p, or 5 minus p. All right, so if I multiply this term by 5 minus p, that cancels the denominator. So I just have plain old 5 minus, same thing here. I'm left with just the denominator, equals negative 10 plus 2p. Careful with those negatives. I'm going to go ahead and move everything to this side so that my coefficient of p squared is positive, even though I'm going to write it over here. I know you guys love how much I mix it up. So add it over here, p squared. Then I'm going to, I have plus 2p, and then minus 5. So I have minus 15 equals 0. So you have to decide if that's factorable. I know if I multiply 3 and 5, I get 15. If the 5 is positive and 3 is negative, those two things add to make positive 2. So I'm going to factor it to be p minus 3, p plus 5 equals 0. So p equals positive 3 and negative 5. Obviously, you want to go check. Would both of those work? Go pause the video if you need to. Store 3, put it in. And then once you have this typed in, if you just restore your calculator for negative 5, then you can press the exact same keys. You don't even have to type all that in again. But you do want to take the time to check. We could even do it real quick if you wanted. If I plug 3 in, I have 5 over, so I have 5 halves, minus p squared would be 9 over 5 minus 3's halves. So I have negative 4 halves, which is negative 2. And then I can also plug negative 5 in. So then that would be 5 over 5 minus negative 5 is 10. So that's a half. Minus p squared would be 25 over, we're going to have 10 again. So that's negative 20 tenths, which is negative 2. So both of those solutions actually do work. And then remember, we have to have our restricted value. I'm going to go ahead and box our solutions. And then we know p can't equal 5. Okay, our last one. Notice that we have 2 binomials, so we're going to have to multiply everything by b minus 2 and b plus 2. So that does get a little bit tricky. So b minus 2, b plus 2. b minus 2, b plus 2. Okay, so thinking through this term, if I already have a b minus 2 in the bottom, that would just clear out. So I'm going to multiply my numerator 2b minus 5 just by b plus 2. I could write b minus 2 all over b minus 2, but remember those would cancel. Minus 2, this term is a single constant. It's got to get both things. There's nothing to clear out in the denominator. Equals, over here, if I'm dividing it by b plus 2 and I'm multiplying it by b plus 2, those cancel. So I just have 3b minus 2. Alright, we've got some cleanup work to do. So I have 2b squared plus 4b minus 5b minus 10. So I'm foiling. Over here, I've got a lot of stuff going on. Be very careful that you're paying attention to what this is going to be. Don't want to do it in one step or two steps. I'm going to go ahead and do it in one step. So this is going to be b squared, so it would be minus 2b squared. Actually, sorry, this is the difference of squares. So this isn't so bad. So I have b squared, and then I have minus 4, but then I have minus 2 times minus 4. You might need to do that in two steps. So again, that would be minus 4, and then if you have the minus 2 on the outside, it would be plus 8. Equals 3b minus 6. Okay, cleanup time. In the same side, I've got negative 2b and positive 2b. Those cancel. I've got 4b minus 5b, so I have negative b. Negative 10 plus 8 is negative 2. Equals 3b minus 6. I'm going to move the b over, so I have 4b. I'm going to move the 6 over, so I have 4, so b equals 1. You just heard the bell, so you know I've got kids coming. You're going to have to go check that on your own, but my restricted values, b cannot equal 2, and b cannot equal negative 2. You're going to go ahead and finish the right-hand column. I'll have a second video of those solutions for you.